life cycle thinking and using sustainable minds in their curriculum to create knowledge workers for the greener product marketplace. Today's guest to talk about using LCA to analyze and visualize possibilities are educators teaching business and industrial ecology, who will talk to you about, again, creating knowledge workers. Our premise is that today making greener products, taking students from education into industry, is all about creating a new economy, and it's all about educating students to take the new jobs and the good jobs that we're creating here at home in North America, as well as around the world. So schools that are integrating environmental sustainability into curriculum are attracting more students, and manufacturers want to recruit those students out of those programs to build a new kind of workforce to create the products of the future. So today we are really honored to have with us Ryan Bouldin from Bentley University and Mark Neo from the University of Oklahoma, who will talk and share their own experience and their own backgrounds of developing these courses, delivering them in their respective schools. And I'll also be sharing with you after their presentations a couple of the presentations that have been shared by other faculty on other webcasts. We found that the registration for today's webcast was quite diverse. A lot of industry folks, as well as educators and consultants across all the disciplines, business, design, and engineering, and to share content that would be relevant and meaningful at the beginning of the school year to all of the registrants. We decided to pull in some of the previous case studies, but all of which are available on our website. All the webcasts have been recorded and are available at any time, and I'll show you where you can go get those. So we're going to kick it off by doing an introduction about Sustainable Minds. I'm Terry Swack, the CEO and founder of Sustainable Minds, followed by Ryan and then Mark. For those of you familiar with using GoToWebinar, there is a questions panel in the control panel, which you can use at any time. We'll take a few questions after each presenter, and we'll also have Q&A at the end. So moving right into our story. We launched the company and the product about 7 years ago, and since Sustainable Minds has been available in the cloud, Sustainable Minds software is being used in over 750 locations in over 75 countries around the world. We were the first to bring a streamlined lifecycle assessment solution specifically created for product development teams to the market, and the first to bring this type of software to the market specifically in the cloud, which has advantages both for us to deliver software and for you, the users, to use the latest and greatest, and also some of the capabilities that are available through the cloud in a way to customize each of your solutions. And we'll talk about that a little bit more as well. We are a mission-based company. Our mission is to operationalize environmental performance into mainstream product development and manufacturing for the purposes of driving revenue and growth through greener product innovation. Now, what we've done is we've brought together two areas of science and design thinking, so Ecodesign and LCA. Putting those two things together get you truly greener products. So Ecodesign is the practice of life cycle thinking and applying new strategies in each stage of the product's life cycle. And life cycle assessment is the scientific method for measuring the relative greenness of products and systems. Just to think differently and teach people to think and design differently isn't going to guarantee a greener result. And just measuring without teaching people to think differently also isn't going to get you a greener result. You have to teach people to think differently and then give them the tools to be able to measure and compare to make informed decisions to get you to a truly greener product. Thinking differently is when innovation happens. Measuring ensures that the improvements are meaningful. So what we're really talking about is environmental performance. And when I use the word green, green is code for environmental performance. It's just the latest criteria in product development that sits alongside functional performance, cost, aesthetic, safety. Manufacturers have already software, tools, metrics for making informed decisions about each of those criteria, but they don't have tools and metrics yet that can be easily used and integrated into the development process to help measure environmental performance and make trade-off decisions not only between environmental performance decisions but also between the other metrics. And now we've got real business drivers creating real market demand for products with better environmental performance, from the cost of natural resources to regulation, particularly originating out of the EU. You've got the challenges of supply chain risk management. We'll talk more about brands, how brands have been able to distinguish themselves by offering products with better environmental performance. And the real opportunity is to bring new innovative products to market that will deliver to you new revenues, new markets, new opportunities that will drive that growth. So environmental performance is an innovation driver that should lower costs and increase revenues. We disagree with the idea that green should cost more. Quite the contrary, environmental performance is a performance metric that should achieve you higher performing products based on the way you're measuring them. So companies making environmental performance a goal will achieve competitive advantage, and it requires new knowledge, new tools, and new processes. Today, manufacturers are facing two key problems. They need and want to design greener products, and they also need and want to market greener products. And this is where the power of brands to create preference really becomes center stage. Sustainable Minds started working with manufacturers some years ago to help them design greener products, but now as green has become mainstream and there really is measurable demand for greener products, integrating greener into marketing and making that marketing statement credible is now part of the software and services that we've added to the Sustainable Minds platform. We're in now the business of helping manufacturers not only design greener products, but market greener products. And it's all about making better decisions, making better design decisions, better marketing decisions, so that your customers can make better purchase decisions. And to that end, we've introduced our Transparency Report program last year in November, and this fall we're scaling it and introducing the complete program and the work that we've done in this past year. And we will be integrating and delivering some of the transparency reporting strategies into our educational space so that educators can start to integrate not just the design capabilities, but the marketing strategy capabilities as well, so that at the end of the day, manufacturers who are making greener products should be able to market those greener products and create a continuous improvement loop so that there is continuous improvement over time. So our focus today in this webcast is on using Sustainable Mind software in early stage product development and teaching life cycle thinking across the disciplines using Sustainable Mind to envision, measure, and model new possibilities in product development. And the number one thing to get folks to think differently about product development is to think about the full life cycle of a product, starting with raw material acquisition to component and material manufacture that goes into the manufacture of products. You've got transportation and distribution between each stage of the life cycle. You've got the use of products, and then you've got what happens to them after the use stage as we look at end of life. That's the complete life cycle from raw materials to end of life. And by adopting that mindset in conceptual design is what enables product manufacturers to analyze, to conceptualize, analyze, and model these new possibilities. And the reason that we created a tool that could be used in early stage product development is this, that 75% of the manufacturing costs are committed by the end of the concept stage of design, and that making decisions that change that design after that are quite costly. All of the decisions that lock in environmental performance of a product are made in this stage, in concept design. So decisions about materials, energy requirements, recyclability, those decisions define the life cycle performance of the product. That's why being able to conceptualize, measure, model, and compare in early stage design accelerates the ability to get to a breakthrough product that manages the risk of innovation early on. So when we talk about eco-design in Sustainable Mind, we deliver content and a framework based on the eco-design strategy wheel that we're showing here that delivers a structured set of strategies that can be applied in early stage design when looking at where are the impacts occurring in the life cycle of the product. These strategies can be applied and investigated to create new alternatives and therefore have options for comparison. Life cycle assessment, as I mentioned earlier, is the scientific method for measuring the relative greenness of products and systems. It's both objective and comprehensive, and it's governed by an extensive set of standards in the ISO 14040 LCA series. The process is fairly straightforward. Doing LCA, you set the goal and scope of the project, like any other kind of project. Building the inventory is developing and collecting all of the inputs into that product or into that product system, and then analyzing the impacts presented in the inventory, and interpreting and making changes and determinations all along the way. In bringing life cycle assessment into the product development world, we tried to bring together terminology from both worlds. So we coined this term a system bill of materials, which is the same as building the inventory. What this slide demonstrates is how all of the inputs across the life cycle of the product can be presented in terms of chemical data, which is called life cycle inventory data or process inventory data. And when those chemicals are put through the lens of an assessment methodology, each of these chemicals can be attributed to one or more categories of impact that impact either human health or the built or natural environment. And that is what the life cycle assessment process is in a very simplified explanation. The way that Sustainable Minds has made life cycle assessment simple or simpler for non-LCA professionals is our single-figure score methodology that's used to be able to create standardized comparisons. All of the science and the underlying data is from trusted sources like the EPA, NIST. All of the data is from EcoInvent or NREL, so the same trusted sources used in the professional tools, and the methodology is 14040 compliant. There's an extensive section in the Learning Center, which is part of the Sustainable Minds application, where you can learn about the calculations, how they're done, and even download the full methodology report. So that brings us to the basic premise of using Sustainable Minds and teaching life cycle thinking, which is that there is no such thing as a green product. All products use materials, they all create waste, they all use energy. That designing a greener product is all about generating concepts and being able to compare. The screen that you're seeing is the concept screen in a Sustainable Minds project where the user starts out by building a reference model. The reference is the first model that gets built. It can be an existing product, or it can be the first concept that gets modeled in a new product exploration. And then each model that gets built, which can be done by copying the reference and changing it up, or building discrete models, each of the models are shown as the relative performance improvement relative to that baseline or to that reference, as well as delivering the millipoint score, that impact factor score, the single figure score, or the carbon footprint. So really what Sustainable Minds enables is eco-concept modeling with real-time LCA results. So Sustainable Minds is based on 3 pillars of software, data, and collaboration. You're going to ask people to do something new and learn while they're on the job. We've delivered an extensive learning center, which is the equivalent of about 100 to 150-page textbook on Ecodesign and LCA, because it's in the cloud, enabling collaboration and knowledge sharing. The primary application for Sustainable Minds is to be able, again, to benchmark and compare, to deliver quantified estimates of environmental performance, again, for non-experts to integrate into product development. It's a credible, standardized system for comparison, and it delivers easy to interpret and share graphical results. This is a quick screen capture of one of the sections of the Learning Center. We have an extensive user's guide that shows you one section around content around the functional unit, and there's equivalent types of content giving examples, small case studies, tabular data, so a lot of reference content in the Learning Center. You're able to model with the data that you need. So we have an extensive data set of generic materials, processes, energy sources, transportation values. But given what it is you want to learn or the products you want to model, we can add data from other public data sources, or supply chain specific, or your primary data can be added to model just the data that you need. The data browser helps you locate the materials that we have, and when you add your own primary data, we can add it to a private data set, or it can be added generically to the public data set so that you can be modeling with your own private data set or generic data. We also created a capability for manufacturers of materials and components to be able to add their branded materials and components through the use of this online data sheet that gives people the ability to specify and put into models in early stage design branded products and be able to connect specifiers with manufacturers, which helps them bring their greener products to market. Our software is used by consultants, other manufacturers. We have a whole slew of case studies and customer stories where they've used Sustainable Minds to dramatically improve the environmental performance of products and create real breakthrough solutions. And each of these customer stories talk about what the problem was, what the results were, the decisions that were made, the eco-design strategies that were utilized in each life cycle stage, and the key learnings. We've adapted this structure for a presentation by our educators so they can tell that very same story, but also wanted to make that story accessible to other educators so that they could understand how they could get started. It's one thing to get started designing greener products in manufacturing. Lots of folks have to learn new stuff, but it's the same thing in education, where educators also need to learn new stuff and apply what they know to integrate it into their courses. So effectively, educators are designing new innovative products by creating new innovative curriculum. And what we're showing here is simply Sustainable Minds can be used to model very simple products and answer simple questions, and it can be used to model more detailed products and answer more systemic questions. I threw in a very quick customer story to make the transition between industry and education. This is one of our customers, the Ecodesign Center in Wales, which is a government agency that makes available to industry and education consultants to go and help them integrate eco-design thinking into their product development process. So we were really excited about this convergence of industry and education with the government mandating that eco-design thinking be integrated into the product development being done in Wales. So that brings me to Ryan Bouldin, assistant professor at Bentley University, who will share the curriculum that he's developed to integrate systems thinking for undergraduate business students in industrial ecology. To kick off the corollary in industry, thinking differently about the products that get brought to market. So Ryan, I'll let you do your own introduction.
Great. Thank you, Terry. Okay, so here we go. So by training, I am a chemical engineer and a green chemist. My current position is I'm an assistant professor of sustainable chemistry at Bentley University, which is a little bit of a head scratcher because Bentley University is a business school, but we do offer arts and sciences here, and we do our best to integrate our students and really train our students for new technology and innovative economies. And so the courses that I kind of touch on that are here at Bentley are a consumer chemistry course, which is really a try to rethinking a product design course in the context of a consumer class. We do a little bit of material science in that class. We do a little bit of core chemistry, and we teach them a lot about environmental health aspects and toxins in consumer products. The course I'll be talking to you about today is really the industrial ecology class. I'll get into that a little bit more later. Kind of my research interest at Bentley is really using enzymes to make polymers in a bunch of applications. But overall, what we're trying to do and what I'm trying to do here at Bentley is to train the next generation of kind of business leaders about sustainable products and try to give them the best way to kind of implement those. And then while I'm at it, I try to show them how to do at least the first steps in the laboratory with my own practice and research. So about Bentley, we are a business school. We're predominantly, we're 4,000 undergraduate students. We've got about 2,000 graduate students in our MBA programs. Housed within the Department of Natural and Applied Sciences, which is my department, we have 4 standalone majors. Most of our students are in what we call our complementary liberal studies majors, where the students have a core business focus, and then what they do is they take all of their liberal arts credits together, roll them into a given concentration, and so what you wind up is a more diverse undergraduate that really has, say, a background in finance, but also understands sustainability, and so they're kind of a perfect match to go into, say, sustainable investing. Again, we are primary, because we're a business school and we're a science department, most of our students are just housed within the undergraduates. We do get the occasional MBA student that is interested in innovative product design or healthcare in particular, is where we see most of the crossover into the business. Okay, so the course where I use Sustainable Minds is my industrial ecology class. I offered it for the first time last fall here at Bentley. I had taught it 2 times previously at College of the Atlantic up in Bar Harbor, Maine. And if you're not familiar with industrial ecology, simplistically saying it is really an idea of quantitizing sustainability. And I know people may argue with that definition, but I've kind of put what I put up as my course description here and bolded the important words here, where really we're looking at systems-based and systems engineering and complex balances, really, and I strive to look at solutions. And we're looking at solutions that kind of embrace and proliferate technology. There has been this view of opposition between sustainability and the business environment, and this course is really one where I try to say that these two can really meld together and actually produce a better product by actually getting together and really looking for symbiotic opportunities there. So my students, again, are most undergraduates. They tend to be mid to upper level. We do have 2 freshmen that bravely sauntered into the classroom that probably got lost, but they got stuck last term. But overall, what we're trying to do here in the class is get the students to kind of understand the interconnectedness between systems, right? And this is at all types of scales, whether it's the local scale, whether it's the regional scale and global scale. And really that is kind of a model for looking at supply chains in general, okay? And then finally, the kind of big takeaway is that there are some triple bottom line aspects that come along with looking at a class like industrial ecology, right? And that's really looking at defining a sustainable relationship between industry, society, and the environment. So how do I integrate Sustainable Minds actually into this industrial ecology class? Well, it's actually a core component. If you've taken an industrial ecology class before, you'll know that LCA is integral component of it. Typically, I put the assignment right in the middle of the course. So we start in week 3 of 13 and go through week 6. It takes up roughly 20% of the total class time. And really, what we're trying to get out of it is to visualize and have students start to take that first shot of connecting things. Like, it takes a lot more than just materials that go into a product. You have to have workers, you have to have supply chains, you have to have transportation. And really, this is the first time that I make them try to put it all down on paper and actually create visuals of it so they can get a better understanding, grasp the vastness of what it takes to create a given product. And so really the results I'm going to be sharing with you today are images that the students produce themselves in their projects. And I'll kind of walk away with the takeaways of what I see the students get out of the project. Okay, so here is the first thing that they do, and it's really mind-blowing to the students. They take an object, they bring it into class, and I have them rip it apart. And so this student brought in a ski boot and was quite scared, in fact, when I said, you've got to rip that thing apart, right? And you need to identify every single material within it. You need to take it over and put it on the scale and find out exactly what it is. You need to look at adhesives within the system. And so this is really my way of integrating material science into the assignment. And they actually love it once they buy in. So the second thing that they really get is the presentation part. Once they've already done the LCA, one of the big things is that they've got to realize that the company that produces the product is actually much more than just that given product. It has a much more greater responsibility. And so one of the parts of the assignment is that they actually go and look at, see if the company has any corporate sustainability reporting, if they have a report that's written up. And so they kind of get a good idea, right, that where the product is actually made, right? Does their manufacturing actually harm the environment? Do they have policies? Do they actually have a safer chemical policy on the books? Okay, and so that would really be a first place to look if you're looking to redesign a product. Well, if the company culture doesn't support a safer chemicals policy, that would be a good place to start. Okay. Because they're doing company research, it's vital for them to also look at what the marketplace will bear some ways of the product, and so they actually look at the numbers. So what is in this case we're referencing the ski boot here, so they're looking at what does the ski and snowboard industry look like in terms of snapshot, and then what does the specific marketplace look like. Okay, and so this helps them define the product impact more broadly. So this is the economic impact aspect of it. So in terms of visualizing the actual impacts, okay, this is where we get into the environmental impacts. And so if we go back, you look at corporate sustainability reporting as being the social impacts. You look at the product market research as being the economic impacts. And then when you look at what the LCA actually puts out for you, that's the environmental impacts. And so this is where the students actually get to see, well, what does it take to actually make something? So they get a list of materials. And they see that, in this case, the actual sans plastic here is the material that if you were going to redesign this, this is where you should focus your energy. And that's very clear from this diagram here. And Sustainable Minds does an excellent job of creating this visual for you. They also get a good image of the life cycle impacts here in terms of what the energy uses and what the overall impact would be. And so in this case, this is a dehumidifier here. This is actually my dehumidifier that I brought into class and the students destroyed, where you can see that it produced a little bit of non-intuitive results here. In my perception would have been that the actual operation of the dehumidifier was consuming the most energy in this case, and then correspondingly having the highest overall impact. But that's not the case here. What we see is that the manufacturing does. And so for the students to then go back and say, wow, if we're going to reformulate here, we really need to focus on our manufacturing industry and worry less about energy efficiency in terms of the product's actual usage. So all of this kind of leads into starting to visualize what the actual supply chain looks like. And so here, this is a pair of Vans shoes that the students tore apart. You'll see here that they start out by making this diagram where they have the material uses and the given impacts of each given material. This is taken exactly from the diagram on the previous page. And you see here we can focus in on canvas here, which is predominantly made of cotton. And so I asked the students, can you actually draw up what it would take to actually make cotton and the interconnectedness of that? And so then the students will bring in a diagram like this, and they start to realize, wow, cotton just doesn't grow in the field, right? There's a lot more that goes into creating this canvas material than just someone going out and actually picking cotton or cultivating the cotton. And so this is really where they start to see, they start drawing lines and start getting connected. Each one of these has an operation. Each one of these has people embedded in this operation. So it's a really, really good eye-opener for students to just start to do that for a single material. And then what I do is I have them do this for every material, or at least the major materials in the given object. And so here, this diagram is fairly complex, so bear with me as I try to explain it. So here is the object. The main object was this student had a power drill, and they broke it into the main components, which would be the case, the screws that hold it together, the chuck of the drill, the clips, the gears, and the motors. Okay. And as you go out and flesh out to the next layer, you can see here that steel, okay, is contained in each one of these, right? And so you start to see a supply chain form here. where you've got this one component contributing in all of these different areas. And so then if we blow it up and look at another given component here, which would be polycarbonate, okay, which would be most of the casing, okay, you start to look at the chemicals here that are involved, and you can look at here, to make polycarbonate, it's a polymer made up of phosgene and BPA, okay, and you can track these all the way back, right, to basically looking at the natural resource flows where you've got some of it coming from crude oil, some of it being produced from natural gas, and then some of them being produced from salt water, right? And it also produces, when they actually do this, you may see that you have some unexpected liabilities down the road, such as having to deal with some marketing aspects of containing BPA. Now, while you wouldn't expect people to be worried about BPA in their power drill, nevertheless, it can still produce some bad press. And so the company should view that as a liability in some ways, potential liability. So when you put all these things together, right, you get a full diagram of what the supply chain and the interconnectedness of everything it takes to make a given object. And you see that it's pretty vast. And you've got a giant roadmap of how everything is interconnected. And so this is really powerful for the students to see, and to see that it's really complex to make something so simple as a drill. And I think this is really, really beneficial for students, that it's not an input-output based system. There is a lot more going on than creating, there's a lot more going on to create a given object. And so finally, for the really ambitious student, we sometimes have them, and this is open to them if they want to do it, go and actually create a new product. And so in this case, I had an artist in my class that was using these Copex sketch markers. When she initially did her LCA, it popped up that she was using, that they contained a non-ionic surfactant. So typically non-ionic surfactants in some ways can be, or certain classes of them can be toxic to aquatic animals. And so in conjunction with Green Screen, which is a safer chemical screening tool, she went and developed a completely reformulated ink, and then was able to actually create all of these images, and this was kind of her PowerPoint presentation, to put all of these things together and drew them all out with her inks. And so she's still actively doing this, and so this project has spurred further research into safer products, in this case for her, and a safer art supply. Okay, to summarize all of this, the kind of key learning aspects for the students, really, using sustainable minds as kind of the core emphasis for which all of this project kind of builds around. It really magnifies the importance of an everyday decision or an everyday object, right? It gives them a good introduction to supply chains, right, and sustainable business practices, right? But it also blows up the magnitude that materials are more, products are more than just the materials that go into them, all right? There's workers involved in it, there's economics involved in it, right? And so really what you wind up with when you can use sustainable minds, or at least how I use sustainable minds, is you really get a transdisciplinary research project where you've got aspects of management, corporate communication, marketing, science, engineering, and ecology there. For the educators on the line, I will tell you that Sustainable Minds is easy to use. So I wanted the tool that I could introduce to the students in about 30 to 45 minutes and have them playing with it by the end of that class time. And then within 3 weeks, have them actually producing top quality products out of it. And I've been very, very happy with the results. So this will be my 4th semester using it. I will continue to use it, and I'm thinking about adopting it into my consumer chemistry class as a product design tool. So if you wanted a fun way to introduce systems-based thinking or systems-based learning, I think Sustainable Mind is a valuable tool for that. So, the kind of trends and the takeaways that I want my students to know when they're actually looking to industry, and some of this is the academic pointing at industry, saying is that really, I'm trying to train you to address complex decisions, right? With a core emphasis on this systems-based thinking. It's not a linear thought process. Things are interconnected. It's not always so simple. Right? And I want them to embrace technology, right, and strive for innovation. Push your company to create new things. Push your company to create new ideas, right? And also to push them to move beyond this kind of linear-based thinking and linear production models, right? This is the material pipeline as we view it, and I challenge them to rethink this, you know, whether that is a cradle-to-cradle design, circular economy type thinking. I kind of leave that up to them to kind of push and explore that on their own. We go into that later in industrial ecology, but in terms of this assignment, this is really where I leave it. So I find it to be a valuable tool overall. So with that, I'll let you tell Mark how he introduces sustainable minds to his students. Thank you.
Thank you so much, Ryan. That was very inspiring, and the supply chain diagrams, fascinating. I can imagine students have a eye-opening experience as they connect all those dots. Well, let's move forward, and I'd like to introduce Mark Mio, who is a professor of geography and environmental sustainability at the University of Oklahoma. And we are so proud to have Mark on this webcast as he presented several years ago when he first started using Sustainable Minds in his courses at the University of Oklahoma, and came back with some pretty interesting findings after his first semester. So we're thrilled to have him come back some years later and talk about how his curriculum has evolved and how his own learning has evolved, as well as the sophistication of the students' projects. So Mark, take it away.
Thank you very much, Terry, and hello, people. Right, I'm speaking from the University of Oklahoma, and I have a background in ecology and policy, and I worked in applied policy programs. Got very interested in environmental issues through my graduate school days and through my years as a professor, and got very keen on the program of environmental sustainability that was being developed here in our Department of Geography. We ultimately changed our name to reflect that. But next slide, please. We launched our undergraduate degree program in environmental sustainability back in 2011. We offered a variety of options with our undergraduate degree, but the enrollments have grown very, very quickly. I can't stress this enough. We are the fastest growing unit on the campus. We attract highly motivated and enthusiastic students, and we're very pleased with the program. Next slide. The life cycle analysis course is taught as upper division. Basically, it's giving students both a conceptual and a practical understanding of how LCA can be used and applied to solve problems. It's one of our key technical skills for the undergraduate major. My particular challenge, however, designing this course, was to find a software program that beginning students could use easily, and they could basically not be reliant on the GIS labs and the other computer labs on campus and in the department. I discovered Sustainable Minds literally through an internet search, and I was quite happy with it. We offered the first course back in 2011 with 7 students, and by 2012 I had close to 30 students. Next slide. Okay, the way I envision the term assignment was built around the book I used. The text is written by some Australians who do a very nice job of explaining the evolution of LCA in Australia, but I needed to give the students some hands-on experience. Basically, I give about 10 class periods to the Sustainable Minds project, and at first I used the tutorial that's provided in Sustainable Minds. I thought the students would get a lot out of it, and in fact they did. But I was not happy with the students' use of the tutorial, simply because certainly some students commented they could do it literally in half an hour. I know some students were challenged by it, but the overwhelming majority of students really were looking for more difficult things to do. So next slide, please. So I rethought the way I was using Sustainable Minds, and I expanded it somewhat. I decided that the students would in fact use the Toaster project as exactly what it was intended to be, a tutorial, and then I would allow the students to sit down using what they learned from the tutorial to scan the literature and select published reports on products or processes, primarily products though, of anything that was of interest to them. And I have some examples here, from air hand dryer redesign to artificial Christmas trees and surfboards, that students picked to basically take the published data from the literature, put it into the bill of materials in Sustainable Minds, and redesign the technology to make it even more environmentally friendly. Next slide, please. And since these students all did what I thought, in the examples I've given you, such a good job, we wrote up an article that explained not only how we came across and adopted Sustainable Minds in the class, but how the student projects are designed and how well they did. The paper that describes this process is now accessible on the Sustainable Minds website. I believe it's right on the blog section of the splash page when you log on. Next slide, please.
Yep.
This is an example of Justin Henry's redevelopment of the eco-friendly coffee maker. He designed 4 alternatives and compared them using the Sustainable Minds indicators, and he gave a justification in his write-up about why he chose the one he did, and it gave him an opportunity to explore in far greater detail the production process and the supply chains of the different inputs to the eco-friendly coffee maker. Next slide, please. So one of the things that we have observed, certainly I have from my students, was that the software application and the exercise is extremely beneficial to the students and gives them a legitimate sense of accomplishment beyond taking exams and telling me what they've read in the book. The SM software, because it's cloud-based, is very good at allowing students to work at their own pace and figure out how to solve problems. Some students developed an improved understanding, but several took the course, then their projects, and found that they got clear direction as to what they wished to do when they left the university. And the nice thing about the Sustainable Mind software finally was it is so diverse, and the students discovered some limitations in the database, but I told them to stay tuned because the database keeps on getting expanded. But it's so diverse that students had no trouble picking all sorts of different projects that they could evaluate using the software. Next slide, please. Okay, and so first learning I got as an educator is I was really stymied. I did not want to pay a large site license, and I really had a space constraint in terms of computers that needed downloaded programs. Sustainable Minds was a tremendous application from my point of view. Also, the trial period offered by Sustainable Minds is very helpful for the students. It gives them a nice opportunity to get used to the software. And next thing is the students create their own sort of buzz. When they enjoy the course, they talk about it, and they talk to other faculty about it, and of course, this mushrooms in our growing enrollment. One of my students told me, because she did such a nice job, and it was very clear in her mind how she did it, that she was very happy to repeat in a job interview exactly what her knowledge was of LCA, and it helped her, quite frankly, acquire a job. Next slide, please. Okay. So one of the things that we have done with LCA is it cements its role as a very important course in our undergraduate curriculum. We have started the master's degree curriculum just this year. It's a 2-year program, And I will now have the cross-listed undergraduate, graduate designation for the course. And the graduate course will have more design issues challenging the graduate students. But at the same time, my students now, we're about 4 years on the road, have taken jobs in cities and elsewhere. They talk about what they've learned, and I now get people asking me whether or not the course will become available online or whether or not I'll be teaching it as a short course and so on. And the course basically affirms for students what they're observing around them. The policy initiatives such as California's low carbon fuel standard is a very nice example of how public policy is emphasizing the need to take systems thinking and translate it into meticulous analysis. And the students feel quite prepared, I think, when they view what's going on in the current world in terms of how they're prepared to take on the challenge for the next job. Next slide, please. Okay, now one of the things that I have as a takeaway is being in Oklahoma, as you can well imagine, we are obligated to justify these sorts of activities. I find the Sloan Management Review and other business management surveys to be extremely helpful in communicating to my administration why what we're doing is relevant and important. We actually have won support for undergraduate degree programs from the College of Business, as well as other folks who I've reached out to literally to help as advisory board members. And we've talked with industry leaders about our curriculum, and we wish to develop, and one of my goals is to develop closer relationships through these kinds of courses with the private sector. And as I pointed out in the last point, we'll probably be expanding our application of LCA-oriented research as our graduate program expands. Okay, next slide, please. Oh, I'm sorry, that was the final slide.
Thanks, Mark. That really is an inspiring story, and certainly makes us proud to have you as a customer and to see the great work you're doing there at the University of Oklahoma. I'm going to share with you now one or two other case studies that other instructors have provided to give you a broader overview of the kinds of projects and the kind of curriculum STEM is being used in, because it really is being used in every discipline that reflects who's involved in making decisions about products in industry. Also, please think about your questions. There's a couple coming in that we can answer towards the end, which we're coming to. But this is one educator, Richard Braunstein. He's been teaching sustainable minds also for a number of years, like Mark, in the School of Industrial Design at the Georgia Institute of Technology. Now, he himself is an industrial designer interested in sustainability. And the course that he's put together is an introduction to sustainable product design. So again, industrial design, third year and graduate students, so third year IDs, they're seniors. And so what he does is really teach the whole sustainable design process, talks about, again, life cycle thinking. He uses a variety of texts to support that curriculum. And so this is kind of looking at its whole toolbox of references, idea creation, and tools. And so what he's showing here is that in the project, a student will select, this is very typical, a handheld device or some small appliance. And he'll show here how students will explore different design alternatives by applying the eco-design strategies, and through applying those eco-design strategies, what kinds of innovative ideas get expressed in new product concepts. what's really nice about this project, and especially in design curriculum, is that Richard still requires that his students draw and use and develop their hand skills and not just work with the computer. And as these concepts evolve, he shows how they evolve not only formally using more sophisticated form creation tools, but then how through the creation of forms, they're applying the use of sustainable minds to measure, model, and compare and evaluate those different design options, again, to ultimately come up with a final solution that they can support and substantiate in a final presentation to customers or senior management or whatnot. So they come out of this course really thinking from a life cycle perspective, yet being prepared to be consultants or be working in industry to be able to present and substantiate their recommendations. I included this one last story given by Arlene Birt, who teaches at the Minneapolis College of Art and Design, and she really has created a very innovative course. She herself, she refers to herself as a visual storyteller, and her work focuses on visualization and sustainability communication. This course, she's entitled Life Cycles, Measuring and Communicating Sustainability Information. And what's very interesting is that her students who have taken a basic course taught by another professor where they're taught to use sustainable minds will take a project, take a product, very simple one, break it down. It's very common doing a tear down of an existing product, like Ryan demonstrated, and then use sustainable minds results to inform how to visualize those results in a marketing or external communication kind of way. So earlier in some of the other results, you saw the donut chart or the stacked bar. She's having her students build the model, get the results, and think about how to communicate those results very simply through visual communication to tell the stories about environmental performance and the choices that manufacturers and consumers can make. Given that we're coming to the end of our time, I'd like to bring it back to where we started, which is that it's all about jobs in the economy, product manufacturing, coming back to North America, creating knowledge workers who can create new, innovative, greener products. Mark gave a great example of how by integrating environmental sustainability into the School of Geography's curriculum has really accelerated enrollment quite substantially. And he also shared one example of a student who was able to get a job because of that curriculum. But we're seeing examples of that even more consistently. And what we're also seeing, and what I'd like to suggest to the participants on this webcast, is that the integration of manufacturers and education, that's certainly a very common relationship in R&D, but this is a really great opportunity for schools to connect or reconnect with the schools that they already have relationships with through projects around environmental sustainability. So schools can be reaching out to manufacturers, and manufacturers who would like to learn more and do R&D can sponsor projects in the universities in which they have, with which they have relationships. Again, the software is easy to use and affordably priced. So anyone can go to our website, sign up for a free 15-day trial account. You can purchase a single subscription online. $350 a year for educators. It's $49 for 6-month subscription for students. And we also have quantity discount pricing, starting at essentially a classroom level and going up all the way through a site-wide subscriptions, class department, school subscriptions, and we have pricing for even larger quantities and larger programs available upon request. We also have a curriculum library where educators who have been teaching with Sustainable Minds have graciously provided us their curriculum. We've put them all into a standardized format. If you'd like some ideas about how to get started or how to integrate a project or a course into curriculum, we are free to share these courses with you. We actually have more than this. They didn't all fit on the slide anymore. And we have all of the webcasts on our website, in our blog. This one has been recorded. It will get posted right alongside Mark's paper, which is also there, as he mentioned. Pretty much the questions that folks have posed are having to do with subscriptions and purchasing or becoming an advisor at their own schools. And we're happy to follow up with each of you individually on those questions and those key points. You can email us more questions, as I mentioned, and we'll follow up with you. But I do want to thank you all today for taking the time out of your busy schedule to listen to Mark and Ryan share their experiences. And we hope you've been inspired by their experience and the stories that we've shared to consider integrating life cycle thinking and Sustainable Minds into your curriculum as well. So we're going to sign off and wish you all a great day, and many thanks to Ryan and Mark for sharing their stories. Have a great day.